Welcome to this video on Target JEE. I'm Shiva and I'm here to take you through to the very first organic chapter, which of course is Nomenclature of Organic Compounds. Without further ado, I request you folks to support us by sharing and liking this video. And not only that, of course, you have to go ahead and then subscribe to our channel as well, right? So let us get to the chapter. If you look at this chapter in terms of getting a foothold, a very necessary foothold at that into organic chemistry. Now, organic chemistry happens to have a wide variety of compounds. So we need a systematic process to be able to name each and every one of these possibly millions of compounds. Now, let us take a look at the significance of this starting point for your journey in organic chemistry, that is nomenclature. To start with, of course, we have different exams, the JEE main exam as well as the JEE advanced exam. Let us begin with the JEE main exam, which is of course the stepping stone into the JEE advanced exam. So why don't we take a look at a table that illustrates the weightage along with the different types of questions that have been asked in the previous years. Now, I'm actually having to struggle to find questions from the very recent past. So here is the table which broadly gives you an idea, a bird's eye view of what all kinds of questions, their types and weightages that have been asked in this kind of exam. Next up, we'll take a look at the big gun. Yes, it is going to be the elephant in the room, which is the JEE Advanced. So take a look at this particular table. Once again, not a lot of questions actually outright come from this particular topic as far as this exam is concerned. Having said that, in 2017, there was a phenomenally easy, highly scoring, but tricky question that ended up tripping up a lot of prospective students who otherwise wanted to do really well in this exam. So simple though it may be, it may not be easy. There is a distinction. Yes. But apart from that one question, if you look at the other types of questions, we'll have to look at topics, or rather other chapters and topics that also involve nomenclature as a part of the trickery of or the complexity of the question. Just out and out, it is very rare, like in the case of 2017, that you actually encounter a question which purely comes from this simple but complicated domain. Yes. You already know what organic compounds are. They're compounds made of mostly carbon, probably some hydrogen, and maybe other atoms like fluorine and so on and so forth. Fluorine, oxygen, and so on and so forth. Yeah. So this family happens to be rather large with a lot of many different kinds of compounds included within. So how do we classify this rather big family? To start with, take a look at this complicated table. At the very top, we have organic compounds, which of course is classified into aliphatic compounds and cyclic compounds. Let us just focus only on the aliphatic part of it. So right now, these two could further be divided into straight chain compounds or branched chain compounds. Now, if you look at the straight chain compounds, as the name suggests, it's pretty self-explanatory. The whole thing has just one carbon skeleton with no branches whatsoever. And as for the other group, as in the branched chain compounds, you see that this carbon atom, this carbon chain or skeleton rather, is actually broken into other substituents which also contain carbon atoms. So there are going to be substituents and possibly even substituted substituents, and this can go as far as much as possible because carbon of course involves catenation. We'll stop with that. Now let us focus at the cyclic part of this whole humongous structure. Now we could either have a cycle or a ring formed only by carbon atoms, and they would be called as homocyclic. And as for the other part, now they might include carbon atoms, of course, and also some other heteroatom like oxygen, sulfur, nitrogen, and so on and so forth. So the ones which include a heteroatom are very imaginatively called heterocyclic compounds, and the ones which are only made up of a ring or a cycle made up of carbon atoms are going to be homocyclic. Now, if you look at the homocyclic kind, we could have cyclic hydrocarbons like cyclopropane, cyclobutane, and so on and so forth. On the other end of this particular division, we have aromatic hydrocarbons. So these compounds, they exhibit a very special property called aromaticity, which of course we'll explore in the next or subsequent chapters, more specifically general organic chemistry. So once again, getting back to this rather, twisted hierarchy, so to speak. So we have aromatic hydrocarbons, and within them we could either have one kind called benzene or benzenoid aromatic hydrocarbons, and then non-benzenoid aromatic hydrocarbons. The benzenoid compounds would of course have toluene, benzene, anthracene, and so on and so forth, whereas the non-benzenoid compounds will have compounds like azylene. Now, let us move on to the hetero part of cyclic compounds. Once again, these could be categorized into aromatic and non-aromatic. So the aromatic part is definitely going to include compounds like pyrrole, furan, and so on and so forth. There are many of them, pyridine for instance. Whereas the last part of the cyclic, heterocyclic, non-aromatic compounds, now they are going to be crown ethers and tetrahydrofuran and similar compounds. So this kind of concludes a broad classification of what is otherwise an endless array of organic chemical compounds. So this is one way to go about classifying them. Welcome to this video on Target JEE. I'm Shiva, and I'm here to take you through to the very first organic chapter, which of course is Nomenclature of Organic Compounds. Without further ado, I request you folks to support us by sharing and liking this video. And not only that, of course, you have to go ahead and subscribe to our channel as well, right? So let us get to the chapter. If you look at this chapter in terms of getting a foothold, a very necessary foothold at that into organic chemistry. Now, organic chemistry happens to have a wide variety of compounds. So we need a systematic process to be able to name each and every one of these possibly millions of compounds. Now, how do we do that? We have a system, of course, as professed by IUPAC, the International Union of Pure and Applied Chemistry. So take a look at this compound. Here, we have a ring compound where on either side of the ring, the six-membered ring, we have the hydroxyl group, and diametrically opposite to it, we have the chlorine group. So how do we systematically go about naming this compound? We know two things. It's a ring compound and it has 6 carbon atoms. As in the ring that forms, the carbons that form the ring have 6 carbon atoms. So straight away the word root is going to be hex. Since this compound is not acyclic, it is a cyclic compound, the primary prefix automatically follows that it has to be cyclo. Now, between the two substituents, the OH group, the hydroxyl group, and the chlorine group, which takes precedence? It's going to be the hydroxyl group, isn't it? Between these two, definitely hydroxy comes out at the top, whereas chlorine happens to be the other substituent. So we start numbering this chain, this ring, at the carbon bearing the OH group. So that carbon is numbered 1. From then onwards, it quickly follows that the carbon bearing the chlorine atom happens to be carbon number 4. And if you proceed, of course, the other carbon is going to be carbon number 6. So how do we name this? The secondary prefix, of course, is going to be 4-chloro. And like I mentioned, the primary prefix is cyclo, the word root is going to be hex, and the primary suffix, if you look at the chain, the ring, we don't see any evidence for unsaturation. It is going to be a saturated compound, and for that we use ANA as the primary suffix, of course, which gets modified as and when it comes or it goes by the secondary suffix. Looking at the primary functional group, the OH group, it quickly follows that the secondary suffix is going to be an ol, as in OL. So putting it all together, the name of this compound is going to be 4-chloro cyclohexanol. 4-chloro-cyclohexanol. There you have it. So this is the systematic method to go about naming a compound. Next up, let us take a look at the important functional groups and the order of importance, or the ranking or the precedence or priority list that goes with each and every one of these functional groups. To start with, we have carboxy or the carboxylic acid group at the very top. Now, definitely as a secondary suffix, it is going to be named as an oic acid or a carboxylic acid. In very rare cases, it does happen to have a lesser priority than something else which has a higher priority. In that case, it goes by the prefix of carboxy. Quickly moving on, we have the SO3H group, which has the prefix of sulfur, and it goes by the secondary suffix of sulfonic acid group. And then you have, moving along the table, as we move down, we have the priority in terms of carboxylic acid, quickly followed by sulfonic acid group, and then acid anhydride, which has the secondary suffix of oic anhydride. And then, as you can see, we have the ester followed by the acyl or acid chloride or acid halide. And then we have the amide or carbamoyl group followed by cyano or nitrile. And then we have the very familiar aldehyde, ketone, hydroxyl or alcohol group, the mercapta or thioalcohol or thiol group. And at the very last, we have the amino or amine group. So as we go down this table, the functional groups at the top, they take the lowest number or the highest priority. And as we move down this table, the ones at the bottom tend to have the least or lesser priority, relatively speaking. Next up, let us quickly get to the rules of naming an organic compound. Although we just witnessed how we go about doing that in reality, there are a few rules to keep in mind. Now, there are plenty of rules, any number of them. And if we get into all these things, it's going to be really, really complicated. But I'm just going to whittle the whole thing down to just about 3 rules that you have to keep in mind. To start with, we have to select the parent chain for maximum number of principal functional group, which has a higher precedence as compared to multiple bonds, which in turn has a higher precedence compared to the number of carbons, as in you have to select the longest chain, that is. And then at the very last, we have the side chain, as in the number of side chains. We always have to optimize for the things that are at your left. So next up, we choose the parent chain such that we get the lowest set of locants. Now, this has to, of course, follow the first rule, and so on and so forth. So there is a pecking order of sorts. And the last being, if there is a tie between similar substituents, then we resort to resolving the tie or breaking the tie by using alphabetical order. So what happens when we have a compound that has both an alkene double bond as well as an alkyne triple bond? In such cases, of course, we'll have to look at each and every compound in detail. It'll vary from one compound to another. If you look at these two compounds, the one with 5 carbon atoms, of course, will get the numbering from the very first carbon atom, which is the terminal alkyne. As in, this carbon is going to get the number 1. The next is going to be number 2, and so on and so forth. The double bond is, of course, at carbon number 3. It's between carbon number 3 and 4. So overall, we have 5 carbon atoms, isn't it? So definitely, the name of this compound is going to be pent-3-ene-1-ine. So PENT, pent, 3-en, denoting that the double bond is between carbon number 3 and carbons number 3 and 4, whereas the alkyne triple bond is it finds a place at the very first carbon atom. There you go. If you look at the next compound, it definitely has 6 carbons in total. If you look at the first carbon from either side, it definitely has a double bond or a triple bond. Now, we can choose to number from either side. But if you notice, carbon number 3 always has a double bond. In both cases, that is. So, how do we go about naming this compound? In this case, we give the higher priority to the double bond, and that will have the lower number. And that is the end from which we start numbering this compound. So, we have carbon number 1 here, carbon number 3 here, and carbon number 5, where we find the very first instance of a carbon-carbon triple bond. So how do we go about naming this compound? This is going to be hexa 1,3 di-N 5 I. Hexa 1,3 di-N 5 I. So that is the name of this particular compound. Next up, we have a famous, interesting question that came in one of the previous instances of the IIT JEE exam. But the naming convention has since then undergone a slight change. So if we were to go by the actual solution or the answer key for this particular exam, probably will not be completely accurate in terms of the IUPAC nomenclature. To start with, take a look at this particular compound. Now, it has 3 carbons, and there is an epoxy group at carbon number 1 and carbon number 2. So there is a 3-membered ring. This is more like an ether, right? A reactive ether at that. So from the given options, we'll have to choose the one correct answer. And what would that be? How do we name such a compound? To start with, we'll have to number the first oxygen atom, the hetero atom, that gets the first number. So this gets number 1. As for number 2, it could go to either of the carbon. And if you look at the carbon on the right hand side, now that has a methyl group attached to it. And for that reason, because of the presence of a substituent, and we have to ascribe it or give it the lowest locant number, we number this particular carbon as 2. And it quickly follows that the other member, the left out member, is going to be 3. So the name of this particular compound is going to be 2-methyl oxirane. So this is the name of this particular epoxy compound. Often in competitive exams, we have a fantastic question that is part of nomenclature folklore. In such questions, we are often given a benzene ring with multiple substituents. Take a look at this question. To start with, we have a benzene ring which has 3 different substituents. The first of which is the cyano or CN group, the second being the bromine group, and the last one, of course, is the hydroxyl group. So how do we go about naming such compounds? We'll have to keep in mind the order of priority. Now, among the 3 different functional groups, the bromine group, the hydroxyl group, and the CN group, definitely it is going to be the CN that has the highest priority, and thus the carbon bearing the CN group is going to get the lowest number. So we start by naming that particular carbon, numbering particular carbon as carbon number 1. Next up, we have 2 choices. We can go either clockwise or we could go anti-clockwise. Now, if we go clockwise, the bromine atom, it gets carbon number 2, and proceeding thus, we'll end up with carbon number 5 bearing the hydroxyl group. So that is one option, with the set of locants being 1, 2, and 5. As for the other alternative, we can of course start by naming the first carbon as carbon number 1, which is the carbon bearing the CN group. And if we proceed in the anti-clockwise direction, the third carbon would end up with the hydroxy group or hydroxyl group, and the last carbon, as in carbon number 6 of the benzene ring, will bear the bromine. So between 1, 2, and 5, and 1, 3, and 6, which has the lowest set of locants? It is definitely going to be 1, 2, and 5. So we number the second carbon, the carbon bearing the bromine atom, as number 2, and the carbon bearing the hydroxyl group as carbon number 5. So how do we name this compound? Let me just write it out for you. It is going to be it is going to be 2-bromo 5-hydroxy benzonitrile. So a benzene bearing a CN group by itself is going to be benzonitrile. So this is how we go about naming this particular compound. Next up, once again, we deal with benzene ring and multiple substituents. But this time, strangely, with only 2 substituents on the benzene ring on diametrically opposite carbons, we have a question with more than one answer correct from the tables of IIT JEE Advanced. And in fact, this question is as recent as 2017. Yes? So it seemingly feels like a very simple, easy question that a lot of people would get correct, would get right, in fact. But this one can trip up even the really well-prepared ones. To start with, we have this particular compound and we have 4 options from which we can choose one or more than one correct answer. So, benzene ring on diametrically opposite carbons has a chlorine substituent as well as a methyl substituent. If you look at the first letters of chlorine, as in it happens to be the letter C, and if you look at the first letter of the methyl group, methyl, that happens to be the letter M. So keep this thing in mind. So between these two, how do we name them? Yeah. If you look at the 4 options, we have option one of the options as 4-chlorotoluene. The next option is going to be 4-methyl-chlorobenzene. As for the next option, we have 1-chloro-4-methyl-benzene, and as for the last one, we have 1-methyl-4-chlorobenzene. Now, if you have a benzene ring by itself, and one of the carbon atoms is attached to a CH3 group, that would be toluene. So definitely we can synthesize chlorotoluene, any of the 3 different chlorotoluenes, as far as substitution on the benzene ring is concerned. So we can start with toluene, and then we can very easily end up with ortho, meta, or para chlorotoluene. I'm talking about electrophilic aromatic substitution reactions. So for that reason, 4-chlorotoluene is a very, very obvious answer. But do we have a systematic name where we can ascribe numbers to the different substituents? So how do we go about that? We'll have to use the alphabet rule. So the C of chlorine definitely precedes the M of methyl. And don't forget, this applies only when they don't have a very clear-cut pecking order in terms of seniority or priority order. As in, we cannot make a case for chlorine being better than the methyl group or vice versa. And for that reason, this is going to be carbon number 1 is going to bear the chlorine atom, and carbon number 4 is going to bear the methyl atom. So this compound can also be termed as or it could also be named as chlorotoluene. So between these two, of course it's not between these two. We have to definitely pick out these two to get the full allotted marks for this particular question. That is how we go about solving this question. Now, if you look at this question, it seems very trivial, very simple even. But if you are under the pressure cooker situation, which you would likely be in the case of a competitive exam, then even the simplest things can actually trip you up. So that concludes this question. Next up, we have a very interesting problem. Only it doesn't have a benzene ring, but it still has a 6-membered, cyclo ring with, of course, 2 double bonds, not 3, and 2 different kinds of substituents, 3 of them totally, as in 2 bromine atoms attached to the ring, different carbon atoms of the ring, and 1 carbon atom attached to a carbon which already bears a carbon-bromine bond. So how do we go about naming this compound? Between multiple bonds and halogens, clearly it is the multiple bonds that get the higher priority. So our numbering should give the lowest set of locants to either of these bonds. So that is how we start with. But there are 2 different ways in which we could do this. And of course, we'll have to ascribe or give the lowest set of locants at the first point of difference. Meaning, we start numbering here. So that is going to be your carbon number 1. So the second double bond is going to be at carbon number 3. And the next set of locants, the first point of difference, is going to arise at the carbon which bears both the different halogens, carbon-bromine bond and carbon-fluorine bond. So that is going to be carbon number 5. Every other way that we try to number, we don't end up with the lowest set of locants. So what would be the name of this compound? Let me write it for you. Since the first letter of bromo, it precedes everything else, as in chloro. So that has to actually precede or take up the first or the initial part of the name, isn't it? So this compound is going to be, since we have 2 different bromo groups, it is going to be your answer. Now, if you go back to the options, we select this one. Next up, we have a fabulous question. No double bonds, no unsaturation. Instead, we have 2 cyclopentane rings, one attached to the other and the other having an ethyl as well as a butyl substituent. So where do we start? So in this compound, since we have 2 different cyclopentane rings, we go with the ring that already has more substituents. Now, if you look at this compound, clearly, pretty much all the substituents are equivalent in that they are all alkane or alkyl groups, right? So definitely we'll only have to look out for the alphabetical order. Before we do that, we'll have to look at the lowest set of locants, of course. So if we look at the second ring, the one with the more substituents, the 3 alkyl groups, the first of which is the ethyl and then the methyl, followed by the cyclopentyl group. So where do we start? Where do we start numbering this compound? If we start here, this is going to be carbon number 1 and this is going to be carbon number 2, whereas the cyclopentyl group is attached to carbon number 4. This is one way of doing it, yes? What about the other way? So the other way would start with the carbon bearing the ethyl group. That could have the numbering, and the next carbon, of course, is going to be the carbon bearing the methyl group. So that is going to be carbon number 2. And the last carbon, which of course is connected to the cyclopentyl ring, that is going to once again get the number 4. So either way, we end up with 1, 2, 4. So having figured out the right way of numbering this particular carbon chain, how do we name it? So this is where the alphabetical order comes into picture, and thus this is going to be named as cyclopentyl, 1 ethyl, 2 methyl cyclopentane. Now, why did we start with 4 cyclopentyl? The first letter C, that definitely precedes the first letter E of ethyl, which in turn precedes the first letter M of methyl. And for that reason, we name this compound as 4-cyclopentyl, 1-ethyl, 2-methyl cyclopentane. There you go. Now, why don't we deal with a rather difficult problem, or at least an inconvenient one? So earlier we had a question with 2 cyclopentyl rings. Now let us add 2 layers of complexity. We'll make the ring 6 in number, as in the ring will have 6 carbons, and we'll have 3 of those rings. What do you say? So for this question, we have 4 options from which we'll have to choose the one correct answer. So how do we go about this rather complicated looking compound? So intuitively, I think we can say that we can start the numbering from the central, cyclohexane ring. Now, why is that the case? Because it has 3 different substituents. So we'll have to select the ring in such a way, we'll have to select the chain in such a way that it has the maximum number of substituents or functional groups. So we could start with the central cyclohexane atom and figure it out. Having said that, there are 3 substituents. Now, one of these is bromohexyl group, the cyclohexane group on the left, and the other happens to be the chlorohexyl group, which is the cyclohexane group on the right, and the third being the fluorine atom, which is attached to one of the carbons of the central cyclohexane ring. All of these, of course, do not have any semblance or sign of unsaturation. So this is going to be a saturated compound. Now, all we have to do is we'll have to figure out how to start the numbering. How do we get the lowest set of locants? This seems rather convenient because there are 3 substituents and we have 6, members in a cyclic ring. So either way we number it, we'll have to start with the fluorine atom, the carbon bearing the fluorine atom, or the carbon which is attached to the chlorocyclohexyl group. Now, one of these can get 1 and the other, of course, will get the number 2. Now, which is it going to be and why? To start with, we have the lowest set of locants possible when we start or when we give the number 1 to the carbon attached to the chlorocyclohexyl group. So this is going to be your carbon number 1. As for the carbon bearing the carbon-fluorine bond, or the carbon attached to the fluorine atom, that is going to get the carbon number 2. And if we proceed this way, we'll of course figure that the next group is attached to carbon number 4. So how do we name this compound? Since the letter B of bromocyclohexyl precedes the letter C of chlorocyclohexyl, of course we'll have to start naming the compound from that part which has the alphabetical precedence over the C of the chlorocyclohexyl group. Yes, so we start with the position 4. Now you might have a lot of fun watching me struggle to read out this rather long, complicated name. I'm not going to do that. So there it goes. This is how we name this rather complicated compound. So from the 4 options, we choose this one. There you go. Next up, once again, we return to our comfort zones as in benzene rings. To start with, we have two different benzene rings. On one benzene ring, we have two substituents, or is it? So now I wouldn't reveal the surprise here. I wouldn't spoil the problem for you. So one benzene ring seems to have two substituents, as in one bromo group and one hydroxyl group, whereas the other benzene ring, which is attached to the first benzene ring, has a cyano or a CN group attached to one of its carbons. So there you go. The two benzene rings, they are attached to each other via a bond, a carbon-carbon bond. Now, how do we go about naming this particular compound? So if you look at the different substituents, we have two benzene rings, they are attached to each other. So all other things being equal, if you look at the substituents overall attached to either of these benzene rings, then we have the cyano group or the CN group, the bromine group, and the hydroxyl group. Of these three different groups, if you look at the pecking order, the order of priority, it is the cyano group that comes out on top. Yes, whereas the bromine group definitely languishes at the bottom. It gets the highest number or the lowest priority, as in the bromine atom, whereas the cyano or CN group, the carbon attached to that is going to get the best possible priority or the lowest number. So we number this particular carbon as carbon number 1. Quickly following that, we have a substituted substituent at carbon number 3. So if you look at the substituted substituent, right, the first carbon is attached to the parent benzene ring, which of course has the highest functional group as in the CN group. And we see that at the third carbon of the substituent, that is where the bromine is attached to the carbon atom. And moving on in this fashion, we reach at carbon number 5 of the substituted substituent, which has the hydroxyl or the OH group. Yes. Now, how do we name this compound? Yeah. So the name of this compound is going to be It's a rather long name, but let me just put it this way. So this is just going to be a simple case of substituent. And once you figure that out, once you figure out which benzene ring to start numbering with, then we already, it becomes a simple case of starting the substituent's first carbon atom at 1 dashed and then arriving at the bromine or the carbon bearing the bromine atom at 3 dashed and the carbon bearing the hydroxyl group at 5 dash. Now, this is just going to be a bromine beating the hydroxyl case because the first word of bromine, B, it alphabetically precedes the first word H of hydroxyl group. And for that reason, we also give the numbering 3 dash to the bromine atom, the carbon bearing the bromine atom of the substituted substituent. And the rest follows quickly, as in the carbon bearing the hydroxyl group, the substituted substituent is going to get 5 dashed. So this is how we go about numbering this particular compound. What is life without counting problems? So JEE has this strange habit of throwing in a surprise in terms of a counting problem, which quickly devolves or evolves into a PNC or a permutation combination problem in mathematics. Once you figure out the basics of what goes where or where is the chiral center or the stereochemical center, then it quickly becomes just being aware of the patterns, recognizing them, counting them, and also being aware of the possibility that a pattern could repeat itself, where you could count it twice or multiple times, thereby not getting the accurate answer. This question is going to be one such problem, but rather simple. Of course, this didn't appear in any of the examinations. We at Byju's do subscribe to our channel and do like us and do share this video. So we sincerely hope that this question is going to come in the next exam. So we are given three different compounds, and compound number 1, 2, 3, and 4. And this once again is a counting problem. So we have to figure out the sum of position assigned to bromine while numbering the parent chain in the given compounds. There you go. Now, if you look at the general category, the nature or the pattern of the given compounds, we have a 6-membered ring, and each of these membered rings, it has a double bond and also 2 different kinds of substituents, a methyl group and a bromine group, but overall 3 of them in each case. Yes. So what do we know already? Between the methyl group and the bromine group or the halogen group, there is not much in terms of who gets the seniority, but the cake definitely goes to the double bond, so that gets the higher priority. So that is what we need to focus in terms of figuring out the right answer for this problem. So let us just lay out, let us just put out all these compounds and start numbering them. But of course, we only are interested in numbering in the number of the carbon that bears the bromine atom in each case, right? So if you look at the first case, so the double bond is going to get the lowest number or the highest priority. Yes. So there are 2 ways to go about it. There are 2 carbon atoms, of course, between which there is the double bond. So which one gets which? Since the first point of difference as far as the locant is concerned, that is going to be the point where the carbon bearing the double bond is also attached to the methyl group. That gets carbon number 1. Now we could ascribe the carbon number 2 to 2 different carbon atoms, but bear in mind, do note that the carbon double bond gets the highest priority and lowest number. So there is just only one way of numbering. So it is going to be the other carbon atom bearing the double bond is going to get carbon number 2. And likewise, if you actually proceed to number all the carbons that form this particular ring, we see that the carbon bearing the bromine atom is going to be numbered 6. Yes? So keep 6 aside. That is what we need to count. I'm just going to write it down separately. Next up, we go to carbon number 2. So once again, the alkene double bond or the cycloalkane double bond rather is going to get the highest priority. Once again, we are left with 2 different ways of numbering this. But at the first point of difference as far as locant is concerned, so we can number it only one way, as in this carbon, it gets number 1, and the carbon bearing the bromine in the ring is going to definitely get number 3. Once again, I'm going to write this separately. Next up, let's quickly move on to the third compound. So definitely the alkene or the cycloalkane double bond will get the number 1 and 2. And that leaves us with 2 different ways of numbering. But the lowest set of locants at the first point of difference, it's going to happen in only one way. As in, we start with this carbon as carbon number 1, and then carbon number 2, carbon number 3, and so on and so forth. So we are only interested in the number that is ascribed or given to the carbon which is attached to the bromine in each of the 4 cases, isn't it? So that means we are going to add another number 1. As for the last and final of the 4 compounds, this is pretty simple, isn't it? As in, the double bond still gets the highest priority. There are 2 ways to go about it. We can have the methyl group, the first occurring methyl group, at position of carbon number 2 or carbon number 1. So the lowest locant is just going to be the position where the first methyl group should come if we are going to number this compound right. So keeping that thing in mind, we start the numbering in this manner: 1, 2, and the carbon bearing the bromine group as far as the fourth compound is going to have the number 5. So in all, what is the sum of all these numbers? So it is going to be 6 plus 3, 9, 10, and it is going to be 15. So 15 is the number that we're looking for. And that concludes this wonderful, wonderful problem. And that concludes this session as well. Are there any parting thoughts? I would say that, do not spend an exorbitant amount of time trying to go through each and every case in nomenclature. Try to have fun with it. Solve the previous papers, the questions from previous exams, and that would actually, cover up a good deal in terms of covering the terrain, the coverage. So you'll have a lot of variety if you solve these problems first, and then you can later on, if you have time, maybe you can tackle the other much more sophisticated, difficult, complicated problems. So ignore this chapter at your peril, because especially in the JEE Advanced, they could just sneak in with a local name, something like styrene or aniline or any number of pyrogalol, resorcinol. All these compounds, although they have their trivial names mentioned, it could very well be your undoing if you don't know and recognize that particular compound in its form. So nomenclature is very important. Do not ignore it. But this is not the end of the world. It is only the foothold that this chapter gets you into in terms of organic chemistry. So that concludes this session. Once again, I'll have to do it. So please like our videos, share our videos, and most importantly, subscribe to our videos.
For more videos and live lectures on the JEE, click on the subscribe button now.